Hello everyone. So when it comes down to high school math, the first thing that we need to know for sure is, I believe, prime number factorization. So prime number factorization is any number such as 18. You're going to, all right, any number such as like 18, you're going to write into prime numbers. So prime numbers are any number that can be divisible by itself and only one, but one is not. So we start from 2. Next number 2 is divisible by itself, and 1. Next number is a 3. 4 is not. 4 can be divided by 2. 5 is. 6 is not, because 2 times 3 is 6. 7 is. 8 is not, because 4 times 2 is 8. 9 is 3 times 3 is 9. So next one is 11. 12 is not, because 2 times 6 is 12. 4 times 3 is 12. So next one is the 13, and so on. So when you go back to the number 18, in order for you to do the prime number factorization in elementary school level, we do this, something called the tree diagram. So you draw two tree, two arrow, and we are going to find out what times what is 18. So I go 2 times 9 is 18. And you talk to yourself, what times 1 is 9? You go 3 times 3 is 9. So here, at the end of every single tree, so 2, 3, 3 is not only prime numbers, but also they are multiple. When I multiply 2 times 3 times 3, it becomes 18. So the way that we write is 2 times 3 times 3. Sometimes you write 2 times 3 square, but I believe this much is enough. This much is enough, but there is purpose of writing this much, and there's purpose of writing this way too. So let's go over why we need to know. In order for you to master high school level math, you need to actually know prime number factorization, either written on your notebook or in your brain. The reason is we use prime number factorization in two ways. Number one is to simplify fraction. So this is a part when it comes down to fraction, almost everybody that I know do not like fraction because we're not good at it. There's something is a lot more going on, but it turns out to be actually a lot easier than you think. Number two, and the other one is simplify radical. So these are the two main reasons that you need to know prime number factorization. Not only you need to know, you need to master. So every single time you have any number, you need to be able to do prime number factorization. So there's another number, and let's do some other thing. Let's do 72. So you talk to yourself, what times what is 72? If you do not know what times what is 72, for example, do yourself side notes. So you're going to go, okay, 72, who are you? And you go, okay, 72. When you're looking at the last number here, 2 is an even number, and every single even number is divisible by 2. So you're going to write 2, and you talk to yourself, 2 times what is 7? Not there, little less than 7. Okay, 6 is there, so 2 times 3 is 6. 12. You subtract 7 minus 6 is 1. Bring the 2 down, and 2 times what is 12? Here, there you go, 6. So 2 times 6 is 12, and of course you subtract, then you have a 0. So now you know something here, which is, okay, let's choose this one. 36 times 2 is 72. So that's what we're going to write. So 72 is 36, or 2 times 36. And if you are good at multiplication table, then you already know 36 is 6 times 6. And you know 6 is 2 times 3. And this 6 is another 2 times 3. So at the end of the day, you know, let's highlight, 72 is 2 times 2 times 3 times 2 times 3. So let's write in order. How many 2's are there? 1, 2, 3. So I'm going to write 2 times 2 times 2. And there are 2 3's, so I'm going to multiply by 3 times 3. So 72, when I do the prime number factorization, is 2 times 2 times 2 times 3 times 3. Or we could write that as how many 2's are there? So 3 of them, 2 cubed, times there are 2 3's and 3 square. Either way is okay. So use this 18 and 72 to simplify the fraction. For example, if you have 18 over 72, it seems difficult to simplify the fraction, but if we already did the prime number factorization, so 18 at the end of the day, we know this is 2 times 3 times 3. And 72, we already did prime number factorization. It is 2 times 2 times 2 and 3 times 3. They are equal to each other. And remember this thing. Same thing over same thing is equal to 1. And simplify as 1. For example, if you have a 4 over 4, and it is equal to 1, because 1, 1, it becomes 1 over 1. If you have a 2 over 2, it is equal to 1, because 2 goes once here and 2 goes once here. If you have a 7 over 7, then it is equal to 1, because 7 goes once here, 7 goes once here. So if you have a same thing over same thing, for example, 1027 over 1027, then it is still equal to 1, because 1027 goes once here and 1027 goes once over here. So if I abbreviate, so I want you to remember this thing. For example, if you have a same thing over same thing, regardless of what that is equal to 1. So square over square is equal to 1. Triangle over triangle equal to 1. Or star over star is equal to 1. Odded, O-D-D-E-D, odded over odded, O-D-D-E-D, is equal to 1. Same thing over same thing is equal to 1. And this concept, the way that you memorize, will be fine till probably like junior year of high school level math. Later, like a college level, there's something called infinity over infinity, and there's a 0 over 0. They are not equal to 1. They are not. But before you hit this much, besides those are the exception. Besides these exceptions, EXCEPTI exception, everything else, same thing over same thing is 1. And we are going to use this concept. So we already written down 18 is 2 times 3 times 3. 72 is 2 times 2 times 2, 3 times 3. We got it from the prime number factorization. Only thing that you can do is cancel it out. Same thing over same thing become 1. And 3, 3 become 1. And 3, 3 become 1. So all you have is numerator 1, 1, 1. And that's a 1, 1, 1. So if I'm going to rewrite, what I have in your numerator is 1 times 1 times 1 over, that's 1, 1 times 2 times 2 times 1, 1, 1, 1. So 1 times 1 times 1 is 1. And 1 times 2 is 2, 2 times 2 is 4, 4 times 1, so it's a 4. So 18 over 72 at the end of the day is indeed 1 over 4. How easy is that? Another one, let me give you another example. I'm going to stop over here. Okay, so if I want to choose another example, let's do the high school level. They don't use like a big gigantic fraction, so let's use something that you could use every day, like probably like 8 over 16. Let's do that. And you go, some of you guys, you could, when you get used to prime number factorization, you could do starting from the very beginning. Okay, this is going to be 2 times 4. All right, and 16 is 2 goes this 8 and 16, they're both even numbers, so 2 times what is 16? 8. All right, we already done. Do you see that there's the same thing over same thing? 2 over 2, they cancel out, become what? 1. They become 1. So I'm going to rewrite that again. So that is equal to 4 over 8. Wait a minute, I know something about the 4. 4 is actually 2 times 2. And 8 is equal to 2 times 4. Oh, wait a minute, I have a same thing over same thing. So I'm going to cancel that out. Gone. All I have left is 2 over 4. So I'm going to go, hey, that's a 2 over 4. Wait a minute, I know something about 4, which is 4 is 2 times 2. So I cancel that out using another color, let's say. Let's see. They're gone. So all I have become 1 and become 1, right? So I have, at the end of the day, it is 1 over 2. Or from the very beginning, if you're good at multiplication table, it goes, okay, so 8 is 8 times 1, and 16 is 8 times 2, right? So they cancel out, become 1 over 2, same answer. But this is one of those reasons that you need to master prime number factorization. And another one is, number 2, is simplify radical. Radical is, notation of radical is something like this. Notation radical. So radical, when you go to high school, we've been doing square root all this time up to the junior high. And when you go to high school, you're going to use the cube root. Maybe you're going to see fourth root. And you need to be able to simplify, and there is some number inside of it. And you need to be able to simplify the radical. These are called the radical. And radicals, I guess. Right? And there's a name for this guy. This one has a name which is called the square root. Square root. This is going to be cube root. Cube root. And that is going to be fourth root. And so on. In high school, if you know up to the fourth root, then you're fine. And let me give you some example how to simplify this one. So for example, if you have a square root of 12. Oh, I forgot to mention. This is only 2 that we don't write. There is 2. That's why it's called a square root. There's a 2 over here, but this is only 2 we do not write in the department of mathematics. Every other 2 we write, but these 2. So that's why it's called a square root. All right, so let's simplify. In order for you to simplify, again, you need to do the prime number factorization. So look at 12, and what times what is 12? And you go 4 times 3 is 12. And look at 12, oh, 12 is 2 times 2. So if I'm going to write this one, this is going to be 2 times 2 times 3. But don't forget there's a square root, so I'm going to write the square root. Here we go. So another way is we're going to write this one as 2 squared times 3. There are 2 times 2. We write that as 2 squared times 3. All right, we're almost there. And there is another thing that I want you to memorize, which is square root, they cancels out. So if we have, for example, if we have a square root of 3 square root, the moment you see it, they cancels out, become 3. So this is the only thing that you probably remember, pretty much remember. So if I want to rewrite this one, it look like square root of 2 square times square root of 3. This means this. They meant the same thing. If it's a multiply, you can put in the 2 different radical. Anyways, there's a good news. Square root, they cancels out. Now it become 2 times radical 3. So you're done simplifying. There's another way. From the very beginning, you could do this. I found out 12 is 4 times 3, and 4 is 2 times 2. The moment you have a pair, circle that. When you circle that, one of those two, when you have a pair, one of those two will come outside of radical, become 2. And the one that do not have a pair will stay inside radical. So it'll become 2 radical 3. 48. Let's do 48. And if you do not know what times what is 48, you could always try to do this. You look at the last number, 8 is even number, so it is divisible by 2. 2 times 2 is 4, 2 times 4 is 8, so 2 times 24 is 48, and 24 is 6 times 4. You know 4 is 2 times 3, 6 is 2 times 3, and from here all you need to do is pair them. There's a two twos, so pair them. There's another two, one here and one on the bottom, so pair them. From here, one of two will coming outside radical. From here, another two will coming outside radical. And these three will stay inside. So I'm almost done. So 48 is actually 2, and there's another 2, and they'll multiply, and 3 stays inside. So it'll be 4 radical 3. Fairly simple. And example 3. What if you have cube root of 24? So we do the same thing. 24, you have 6 times 4 is 24. 4 is 2 times 2. And 6 is 3 times 2. Since it's cube root, earlier when it was a square root, we pair them. We need to have exactly same two number. But if it's a cube root, guess what? You need to have exactly same 3 numbers. You pair those. They group them together. Then one of those number will coming out. In this case will be 2. And these 3 will stay inside. So my answer will be 2 cube root of 3. Same concept. So if you are able to, the purpose of knowing the prime number factorization in high school level is, I'm going to rewrite this one again one more time, but very big. Number one, so that you could simplify fraction. So remember this, same thing over same thing is equal to 1. And number two, you need to simplify radical. And all you need to know is, depending on the index, the 2 square root 2, this 2 is called the index, this 3 is called the index. Depending on the square root, you need to have exactly same two number and one of them coming out. If it's a cube root, then you need to have exactly the same 3 numbers, then one of them will coming out. That's all for today, and see you next time.